Let's say you have a graph and you don't even know what the function equals to at all. How do you tell that this function has an inverse function? For example, I have so many graphs. This graph can be represented by a function, right? But I didn't tell you what the function is. By looking at the graph, how do you tell that this graph has an inverse function? The answer is you have to use a horizontal line test. So that sounds familiar, right? Because you are thinking, all right, I remember that I learned vertical line test in the past. Yes, you study vertical line test in the past. Vertical line test is for testing the one-to-one property of a function. Basically, you have a graph. You draw a vertical line. If the vertical line intersects the graph at one point, exactly one point, then the graph is a function. If the vertical line has two intersections, then the graph is not a function. But horizontal line is for testing the inverse function. There are two cases. The first case is you draw a horizontal line, you see exactly one intersection. That means that function has an inverse function. For example, all the purple graphs right here. So if you draw a horizontal line, but you have to do it within the domain, right? So it doesn't make any sense if you just draw a horizontal line right over here. So please, did I say within the domain? It must be within the range, okay? Within the range. So don't put it right here. That is out of the range, right? So you don't want to put a line in here. You don't want to put a line in here. You want to put it within the range. Somewhere within the range. Make it horizontal. Like this. Like that. What do you see? I see exactly one intersection, exactly one intersection. That means these two functions, they have an inverse. So the first one is clearly something like a square root of x, and then the second one is a half parabola, right? X squared. They have an inverse. And then this one, the straight line, exactly one intersection, exactly one intersection, exactly one intersection, or you can do it right here and say this is exactly one intersection and then exactly one intersection. So the six graph you see right here, whatever the function represents, they all have an inverse function. That means you can do the algebra to find the inverse function. How to do the algebra, I will show you in the next video. And then on the other hand, the case 2, this one, if you draw a horizontal line within the range, you have more than one intersection. That means this parabola, this full parabola, does not have an inverse. And then same thing for the circle. You draw a horizontal line, you see two intersections, or sometimes you see 3, 4, 5, 6. As long as the number of intersection is more than one, that means whatever the graph equals to, whatever the function is, has no inverse. Now, when you look at a full parabola, this is a full parabola, right? So this is like an x squared, the full parabola. And then the inverse function of the full parabola is plus or minus square root of x. This is the inverse function of the full parabola. Now, the full parabola fails the horizontal line test, right? That means the full parabola does not have an inverse function. What if you insist to do the algebra to find the inverse function? You can do the algebra to find f inverse. It doesn't mean f inverse is a function, because if you draw a vertical line, use the vertical line test, the one-to-one property is failed. The plus or minus is not one-to-one. When x is equals to 1, y can be positive 1 or negative 1. When x is equals to 4, y can be positive 2 or negative 2. So the one-to-one property is failed, right? So when the one-to-one property is failed, that is not a function. That means the corresponding function f of x will not pass the horizontal line test. So the horizontal line test applies to the concept of horizontal line test applies to graph, or you can do it on the table value as well. Do you see this table value? This is the table value of f of x equals to x squared. This does not have an inverse. Do you know why? So for the horizontal line test, you have two identical y, right? So do you see this horizontal line test? Do we agree that we have two identical y? Y is equals to the same value in this case. So all you have to do is you check it. So this, when x is equals to negative 2, y is equals to 4. When x is equals to 2, y is equals to 4. So this one, the horizontal line test failed. So the horizontal line test failed because y occurs twice. Not only just the 4, also the 9 and the 1. They occur twice. So the horizontal line test failed. Therefore, x squared has no inverse. You have to be able to do this on a table value as well, because sometimes they don't give you a graph, they give you a table value instead. And then the last one, do you see that any y occurs twice? No. So this is for the function f of x, none of the y occurs twice, so this has an inverse. F inverse of x, which is what? Which is equals to x squared when x is greater than or equal to 0. But how do you go from the square root of x to x squared? We have to discuss that in a separate video. Alright, so that is the end of this video. If you like it, give me a thumbs up, a subscribe. Truly appreciate your subscription, and I will meet you all in the next one. Signing out.